All right, let's talk about maybe the most exciting moment in model railroading, the first time you bring your creation to life. We're gonna pull back the curtain on how electricity works for your trains and show you how to get started with a super reliable, classic system, direct current, or what we all call DC. So let's dive in. So you've done it. You've laid out all your track, you've carefully placed that shiny new engine on the rails, and now what? You're staring at it thinking, how do I actually make this thing go? You know, it's the first big question for just about everyone in the hobby, but trust me, the answer is way easier than you think. Okay, so everything, and I mean everything, starts with one essential piece of gear. You've got to think of the power pack as the heart and the brain of your entire railroad. It's the thing that's going to pump life into those rails and get those wheels turning. So, what is this thing exactly? Well, a DC power pack basically takes the regular old electricity from your wall outlet and transforms it into a safe, controlled power source for your layout. With just the turn of a knob and the flick of a switch, you are suddenly the engineer. You're in complete control of the speed and the direction. Now, you're going to notice a huge difference between power packs pretty quickly. The little controller that came in your starter set, it's perfectly fine for a simple circle of track, basic forward and reverse. But when your world starts to get bigger, a real hobbyist power pack gives you a massive boost in power. We're talking enough to run multiple engines, light up buildings, and more. Plus, you get these advanced features that just add a whole nother level of realism. All right, let's get that power from the box onto the rails. I know a lot of beginners see wires and get a little nervous, but for a basic DC layout, this is incredibly simple, seriously. That's it. Believe it or not, for an entire loop of track, all you need are two little wires. One wire connects to one rail, the other wire connects to the opposite rail. That creates a complete circuit, and that's all it takes to get your train chugging along. And you want to know the best part? You don't even need to learn how to solder. First, you just swap out the little metal clips that join two pieces of your track, they're called fish plates, for a pair that already has wires attached. Super easy. Second, you can drill a tiny hole right there to run the wires underneath, keeping everything nice and tidy. And third, you just connect those two wires to the DC terminals on your power pack. Boom, you are ready to run trains. So we're powered up. Now let's talk about those cool advanced features I mentioned. This is where the real fun begins. You're not just making a toy train go in a circle anymore. You're starting to operate it like a real engineer, and that just adds this fantastic layer of realism to the whole experience. The first one you'll love is called momentum. Instead of your train just lurching forward from a dead stop, momentum makes it ease into motion, nice and slow, just like a real massive locomotive pulling a heavy load. And when you cut the power, it doesn't just slam to a halt, it coasts to a gradual, smooth stop. Oh, it's a total game changer for how your train feels. But wait, there's more. You get things like an applied brake, which lets you slow the train down for a perfect, gentle stop at a station without messing with the main speed dial. There's often a dial gauge that lets you adjust the power output so it's safe for different scales, from the tiny N scale up to the giant G scale. And maybe most importantly, there's circuit protection. It's basically a built-in safety switch that cuts the power if there's a short, which can save your very expensive engine from getting fried. And here is a critical piece of advice from the pros. Let's say a derailment is about to happen. Your gut instinct is to slam the speed dial to 0, right? Well, with momentum on, the train's just going to keep coasting into that disaster. You have to remember to flip the momentum switch off first to get it to stop immediately. It's a new habit you have to learn, but it can save you a lot of grief. Okay, so your layout is up and running, it looks great, but then you get ambitious. You start adding more track, maybe some sidings, a few switches, and all of a sudden, you've got a problem. This is probably one of the most common headaches in the whole hobby. Your train runs just fine on the main loop near the controller, but the moment it goes onto that new siding or gets to the far corner of the layout, it just sputters and dies. What is going on? The culprit here is a little something called voltage drop. The easiest way to think about it is like water pressure in a really, really long garden hose. It's always weaker at the far end, right? Well, electricity is kind of the same. It loses a little bit of its oomph as it travels down the rails. Over a long distance, that little power loss is enough to stall your engine. So what's the fix? Well, thankfully, it's pretty simple. It's something called dropper wires. All this is just another set of wires that you run from your main power pack directly to that part of the track that's giving you trouble. And that's really all there is to it. By adding this extra direct booster feed to that faraway corner or that tricky siding, you get rid of the voltage drop. You're making sure that section of track gets the exact same full-strength power as the track right next to your controller. And just like that, problem solved. Okay, we've covered the power pack, we've covered the wires, but there is one more critical piece of this electrical puzzle we have to talk about: the track itself. See, it's not just a road for your train, it's a super important part of the circuit. That's right, not all track is created equal when it comes to electricity. The kind of metal your rails are made from has a huge impact on how easily that power flows along it. That property is called conductivity. And if you have poor conductivity, you get more voltage drop and your trains just won't run as well. Just look at G-scale track, for example. The differences are pretty major. Brass is the king. It has excellent conductivity and it's absolutely the best choice for pure electrical performance, but you do have to clean it regularly. Stainless steel is a trade-off. Its conductivity is just okay, but it's fantastic for outdoor layouts because it doesn't rust. And then you have nickel silver, which, funny enough, actually has pretty poor conductivity and usually isn't the best choice if you're powering your trains through the track. And get this, stainless steel is 40 to 50% less efficient as an electrical conductor than brass. I mean, that is a massive difference in performance. It means if you choose stainless steel, you are way more likely to need those dropper wires we just talked about to keep the power consistent, especially on a bigger layout. So what's the big takeaway here? Choose your track material carefully. If you want the absolute best, most reliable electrical performance, brass is your winner, hands down. But if you're building outdoors and you really want low maintenance, stainless steel is a decent option. You just have to be ready to run some extra power wires to make up for it. And there you have it. From picking the right power pack, to making those first simple connections, to solving common problems, and even picking the right track material, you've got the whole picture now. You have all the fundamental knowledge you need to power up your DC model railroad. You are officially ready to be the engineer. So you've totally mastered how to run one train on one loop of track. But what if you wanted to run 2 trains or 3 on the same track at the same time, all doing their own thing? Well, for that, my friend, you have to step into a whole new world. The question is, are you ready for digital?